its research and teaching. The topic of my discussion, soil security and climate change. I would like to present briefly the concept of soil security. It refers to the maintenance or improvement of the world's soil resources so they can provide sufficient food, fiber, and fresh water, contribute to energy sustainability and climate stability, maintain biodiversity, and deliver overall environmental protection and ecosystem services. That's the definition from FAO 2022, based on the work that colleagues at the University of Sydney did about 10, 15 years ago. The terms soil security, soil quality, soil health, soil function, these four terms are similar with regard to the generic goal of sustainable management of world soil resources for provision of essential ecosystem services for human and nature. Therefore, in this particular lecture, I will use these four terms interchangeably because soil resources are also strongly affected by the human ecosystem interactions. And this interaction between soil and human has created several issues which are driven globally by rapid increase in population. The global population in 2024 at present is about 8.11 billion. By 2050, it's projected to be 9.7 billion. By 2100, 11.2 billion. And this population has several other ramifications: soil degradation, runoff, erosion, hydric erosion, and eolic erosion. Globally, water erosion is affected 1.1 billion hectare. Wind erosion affects another 0.55 billion hectare. Then, of course, we have a secondary salinization of land, especially irrigated land in arid and semi-arid region, which affects totally global about 1 billion hectare. But 20% of the irrigated land is affected by secondary salinization. Water quality, this is an example from Lake Erie, northern part of Ohio. Water quality affected by agricultural pollutants, fertilizer, and of course sediments rich in organic matter create a lot of pollution throughout the world. And then, of course, we have rapid urbanization. And urbanization by 2030, at the end of the current global sustainable development era, will occupy about 10% of the current arable land area, total urbanized area, about 152 million hectare. Then we have a loss of species. The 1,000 to 10,000 species per year are lost because of human activity, while the background rate is only 5 species lost per year. And we have deforestation everywhere, including in Latin America, but globally the rate is declining. In 1990, it was 8 million hectare. In 2000, 7.6 million hectare. In 2024, about 3.7 million hectare of land. And then we have water withdrawal, including in Mexico, the drier part of Mexico, very rapid water withdrawal. And we have people living in water-strated river basin, 3.5 billion people by next year. And very scarce water resources, including the dry land of Mexico, the Sonora Desert. And then we have the ever-increasing threat of global climate change. And the global climate change, it's very important to understand that more than 500 gigaton, petagram of carbon has been emitted from land, of which soil loss of carbon is estimated somewhere between 80 to 135 gigaton, 80 to 135. And that causes soil degradation, decline in quality and capacity of the soil's productivity through misuse or diminution of the soil's current or potential capacity to produce food, feed, and fiber as a result of one or more degradation processes. And soil is an important component of land, along with water, biodiversity, and climate, which is very, very, very prone to degradation. The land degradation is human-induced, is accelerating 40% of the land surface in the world in 2024. About 50% of human population globally is affected by land degradation. Ability to feed human population is put at risk by possible decrease in food production, and land degradation reducing GDP, affecting people's health, reducing access to clean water, and worsening drought and aggravating food security. Now it brings me the question of agricultural revolutions in the world. Revolution 1.0, it happened about 8000 BC when the settled agriculture started from hunter-gatherer society. The second green revolution, agricultural revolution 2.0, was from 17th to the 19th century when the mechanization happened, when the trade of agriculture products happened globally. The agricultural revolution 3.0 was the green revolution that started in Mexico, MAP, Mexican Agricultural Program, which is now CIMET. But it was seed-centric. And now I will talk about soil-centric green revolution. And the green revolution 4.0, bringing 2010, artificial intelligence, intelligent computers. So agricultural revolution 1.0, circa 8000 BC, when hunter-gatherer people adopted settled agriculture and farmed villages and towns and created social structures leading to arts, culture, and infrastructure. The food production, agriculture, basically was started by women around 10 to 12 millennia ago. And then, of course, the bullock power and animal draft animal came in very famous epic of Ramayana about 4 to 6 millennia before present time. In the Indus Valley, then mechanization. Europe started agriculture revolution 2.0, 15th to 19th century, from 1750 to 1950, with the use of machinery and fossil energy-based inputs, which increased the land area under agriculture, along with the expansion of land under supplemental irrigation. And then came the mechanization. The steam horse in 1910, plow-based, tractor-based plowing, which caused severe dust storm in the United States, the so-called Dust Bowl of 1935, because of the very serious accelerated soil erosion caused by plowing. Plowing aggravates soil erosion. And then came the agricultural revolution 3.0. You must be very proud of it, because Dr. Norman Borlaug arrived in Mexico in 1944. That was the start of Mexican agricultural program funded by the Rockefeller Foundation from 1943 to 1965, which eventually led to establishment of CIMET, next door to you, where you are located at the Postgraduate College in 1971. And Dr. Borlaug's dwarf wheat varieties, sometimes called Sonora wheat varieties, increased production in Mexico of wheat by double between 1940 and 1960, tripled between 1940 and 1967. And that was the Green Revolution, the so-called Borlaug effect, the miracle varieties. But that miracle varieties, seed-centric approach based on plants which are short stature, caused severe problem of soil degradation, including in Mexico. Loss of soil fertility is observed on 25% of cropland area, and it adversely affects agronomic productivity. More than half of the agricultural soil in Mexico are affected by some level of soil degradation. And the postgraduate studies at your college has done a remarkable work on soil degradation assessment in Mexico. They produced a map at 1 to 250,000 scale in 2003, estimated that hydric erosion in Mexico affect 12%, aeolic erosion 10%, physical degradation 6%, chemical degradation 18%. Congratulations to all of you who did this excellent work estimating the types of soil degradation in Mexico. Green Revolution in Mexico, which happened, was also very intensively based on chemical, especially use of fertilizer. The nitrogen fertilizer used in Mexico in 2021, 1.66 thousand metric ton, phosphorus 0.55, potash 0.33, total about 12.543 thousand metric ton of fertilizer. Coupled with pesticide use in Mexico, between 2007 and 28, Mexico pesticide stabilized at about 53,000 metric ton per year of herbicide, insecticide, and fungicide. Thus, Mexico is behind Brazil and Argentina in pesticide use, but right there in the top 3 countries of the Latin America. Now it brings me to the limitations of the Green Revolution. The Green Revolution, when it happened, including in Mexico and South Asia, India, Pakistan, and many other parts, it was a miracle. We must salute Dr. Borlaug, thank him for the excellent work that he did, beginning in Mexico, very close to where you are. But soil degradation globally affects about 40% of the land area. Agricultural emissions are increasing globally 1% per year, and yet there is a prevalence of undernutrition. About 1 billion people, this figure 820 million, does not include the recent crisis in Eastern Europe and in the Middle East. The number of most recent estimate is more than billion, and there is a malnutrition affecting more than 2 billion people. Dependence on fossil fuel leads to 10 gigaton of carbon per year emission. Water pollution scarcity is aggravating. Urbanization is happening very rapidly. And of course, there's the food waste. And this Green Revolution was soil-centric and cereal-centric. It was not soil-centric, it was cereal-centric. It was focused on 3 cereals: rice, wheat, corn. Rice, wheat, corn, no other crop, cereal-centric. But the Green Revolution has not ended the hunger. 1970 to 1990, there has been a serious problem of hunger. While staple cereals became more affordable, that's rice, wheat, and corn, the price of non-staple food, which are rich in micronutrients, chickpea, pigeon pea, mung beans, legumes, vegetables, fruits, they suffered. There have been increase in soil degradation tremendously. Therefore, the 21st century Green Revolution. We are very fortunate to God that we have Dr. Borlaug, but now we must revisit, rethink what can we do so that soil, water, biodiversity, climate, natural resources are not harmed, not aggravated degradation. Therefore, the 21st century Green Revolution should be soil-based, soil resilience-based, ecosystem-based, because of increase in eco-efficiency, knowledge-based, science and management-driven. Variety, improved variety, the so-called miracle variety, is only one component. Miracle variety cannot do their miracle if they are grown in a degraded soil. Even a miracle variety cannot get water if water and nutrients in soil do not exist. Therefore, we must revisit the Green Revolution by adopting one of the options, regenerative agriculture. Regenerative agriculture is a concept, it's an idea, it's an approach, it's a strategy. It's not a one technology. This strategy is inspired by eco-innovation. It's powered by non-carbon energy. It's driven by a circular economy and green infrastructure. It's supported by the recarbonization of the terrestrial biosphere and the bedrock of sustainable development. Soil organic matter, essential to the soil health, is also the elixir of life. Elixir is an Arabic word called el-aksir. the life supporting system. And that is what soil organic matter content is. Therefore, colleagues, friends, ladies and gentlemen, we should think about agriculture revolution 4.0. And what is that? It involves the use of artificial intelligence since circa 2020. It is driven by cyber physical system or intelligent computer. That's the so-called digital agriculture revolution. Is driven by the urgency to change from performing high productivity via artificial intelligence, such as machine learning, big data, robots, IoT, DSS, cloud computing, to transforming agriculture, which means producing more from less. Less land, less water, less fertilizer, less pesticide. It is environmental centric, soil centric revolution. What is machine learning? Is a computer program which can learn specific tasks without being explicitly programmed to do so. Machine learning is a process involving the use of computer to make decisions based on multiple data inputs. A set of example, machine learning is used to voice recognition, image processing, weather forecasting, natural language processing, and other things. And the transformative agriculture, which is an important component, the use of sensors and robotics to collect field data and transmit it to local or cloud servers via IoT for storage, processing, analysis, and undertaking appropriate decisions via artificial intelligence. Machine learning and transformative agriculture is used in transformation of agriculture by using soil and water sensors, camera, drones, satellites, automated guided vehicle, and communication technology to arrive at management decision. IoT sensors are used to obtain information on soil properties, climate parameters, and livestock factors. The transformative strategies involve changing from system which has led to deplete, degrade, destroy, discard, and dominate, take land from nature by these 5 Ds, and we want to transform it to the improved system, which are based on 5R: reduce, reuse, recycle, regenerate, and restore, and return land back to nature. Return some land and water back to nature. How can we do it? We change from conventional tillage to conservation agriculture, from monocropping to complex farming system, from chemical fertilizer to integrated soil fertility management, from pesticide use to integrated pest management, from high harvest index to high root biomass. Notice the focus is not on producing more grains. We want to produce more biomass, especially more root biomass. That's the difference in concept here. Rather than short-term gains, we want to have long-term sustainability. And from grain cropping, we want to move to carbon farming. And what is farming carbon? It's growing soil carbon as a farm commodity, like wheat, like other crops that can be traded, bought and sold, and create another income stream. So carbon is a crop that you can grow. It's a new crop, and pay farmers for $50 per credit. One credit is 1 metric ton of CO2 equivalent. If you could sequester carbon in the ground on a long-term basis, it follows a sigmoid curve. And from knowing this sigmoid curve on the basis of long-term experiment, you determine the slope of the line, delta Y over delta X. And as it reaches the plateau carbon saturation point, it gives you an estimate of soil carbon sink capacity. It also tells you the duration which it will take, 25 year, 50 year, or maybe 100 year, to reach back to the saturation point, the carbon that we have lost in the past. And this carbon saturation point can be function of soil properties, such as mineralogy, clay content, clay type, depth of the soil, moisture regime, climate, land use, management, and many practices which involve to achieve this would be consisting of nutrient availability, biomass input, root to shoot ratio, the CN ratio of the biomass, the coupling or decoupling of carbon with water, nitrogen, phosphorus, and sulfur, and stabilization and mechanism over and above the mineralization mechanism. This will require change in policy. In the context of United States, we have a Clean Water Act of 1972, Clean Air Act of 1967. We cannot have clean air and clean water without Healthy Soil Act. This is a time to have a Healthy Soil Act. Today, I submitted a request to Ohio legislature making a plea for a Healthy Soil Act in Ohio. Will it happen? I do not know, but certainly there's a need for it. Why there's a need? Because rights of soil must be respected. Soil is a living entity. Just as the universal rights of human, rights of animal, there must also be the rights of soil and rights of nature. And the essence of all life, soils have rights to be protected, restored, thrive, and managed judiciously. Prime agricultural land and ecologically sensitive ecoregion, especially those in drier part of Mexico and elsewhere, must be protected. Therefore, rights of soil. And finally, the mantra that I would like to leave with you is healthy soil equal to healthy diet, equal to healthy people, equal to healthy ecosystem, equal to healthy planetary processes. And this mantra, although it seems difficult, it's not impossible to achieve. I thank you for the opportunity to talk to you, and I very much hope and wish and will plan to visit your great institution.
Well, thank you very much, Professor Rattan. That really was a very nice presentation. So probably we have some minutes for any question.
Dr. Rattan, it was a very nice presentation. I have a question for you. This is a very there's a very important trend in agriculture right now going on, but it seems that not all the world is embracing it. It's about agroecology. What do you think about agroecology?
Yes, that's a very good question. Agroecology is an important concept. It came out at the UN Food Systems Summit of 2021. And agroecology is based on 4 principles. Number 1, everything is connected to everything else. Number 2, Mother Nature knows the best. Number 3, there is no such thing as a free lunch. Everything has a price. And number 4, there is no way to throw away. We must minimize the wastage. So agroecology is based on these 4 principles, which is essentially means do not waste, recycle the nutrients, and observe the law of return. And the law of return states everything you take from soil or nature, you must replace back to the soil and nature in one form or the other. So I think agroecology is a good concept, and it needs to be promoted along with the concept of regenerative agriculture.
Thank you. We are going to be very happy to have you here in the near future.
Another question? Questions from the people that is connected, please feel free to make questions. Dr. Lara.
Yes.
Your presentation talk about programs, but my concern is if the United Nations is considering to enforce this approach, because
there are many poor countries that depends on green revolution yet, and I want to hear your opinion. If there is any way to force this, that the people that take decisions be trained, be conscious, to go to the most high part of the people that take decisions to go some direction, some instructions.
Yes, I think the policymakers, especially in the tropical regions, developing countries, policy is a very important part. And we hope that politicians would consider increasing respect of the agriculture profession, reward farmers for doing better agriculture. And therefore, we need policies which are pro-nature, pro-farmer, and pro-agriculture. And that is why I mentioned Soil Health Act, all soil protection laws are a mechanism by which a policymaker can make provisions to reward farmers for making agriculture a solution to the environment. So not only just producing better and more and healthier, nutritive and safe food, but at the same time, restore degraded soil and improve the environment. I think that is the policy that we are looking for. And one of the part of that policy should be payment to farmer for ecosystem services, such as I mentioned, payment for 1 credit of carbon in soil or trees, rewarding farmer for about $50 per credit. And that will address not only the Sustainable Development Goal number 1, which says end poverty, it will also address Goal 2, which says end hunger, and certainly Goal 6, which says water quality and renewability, Goal number 13, climate action, Goal number 15, life on land and land degradation neutrality, and Goal number 17, cooperation amongst institutions and peace and justice for all. So I think soil health is strongly dependent on the policy, and we need certainly policymakers in dialogue.
Thanks.
I'm sorry for
Corruption. Pero dejan de-
Dr. Rattan, you can listen?
I was on mute. I was on mute. I'm sorry, I was on mute. I'll repeat the question again. I'm
Okay.
sorry. The question was about policy, and I mentioned that we need policies which are pro-nature, pro-agriculture, and pro-farmer. And from that point of view, dialogue with policymaker is very critical. And the policymakers not only can create conducive environment, but they can also help payment for ecosystem services. And I mentioned $50 per credit. So I think policies which are pro-agriculture and which increase respectability of the agriculture profession is very, very important. You also mentioned in the previous question, which I think you may not have heard my answer, the Green Revolution, it should be more now focused on soil and environment. The Green Revolution of the 60s and 50s in Mexico the wheat production went up, was seed-based. It was variety-based, but it was not environmental-based. And we are recommending at present green revolution, which is more focused on natural resources, on soil and water, biodiversity, and on producing more from less, less input, less resource consumption, and hopefully returning some land back to nature. I'm sorry I was unmuted and I was on mute and didn't know. Thank you for letting me know.
Thank you very much for the answer. I have one question, Professor Rattan. What is your opinion about the legislation about soil science?
Soil science, there is a improvement in awareness of its importance. The previous COPs have mentioned soil science. Soil health was mentioned in the previous COP. It was very important indication that policymakers are paying attention to it. And then we had a G20 meeting in Brasilia just a few weeks ago. And that was also involved soil health and soil management. And recently, a very important thing happened in Africa. There are 15 heads of state of Africa in attendance, and they all talked about importance of soil health. So I think a South-South dialogue, for example, countries such as Mexico, Brazil, Argentina, and other countries in South Asia, could perhaps develop a South-South cooperation to support soil-related programs in Africa, sub-Saharan Africa, along with other developing countries. I would promote South-South cooperation in addressing issues which involve soil degradation and use of soil to improve not only productivity and nutritional quality, but also mitigate climate change, increase biodiversity, and restore the environment. So soil is a good thing to promote. I'm also recommending that soil and environment education be promoted at primary school level, maybe kindergarten, where the alphabet books in Spanish, English, Portuguese, they should be oriented alphabets, soil-based, environment-based, nature-based, so that children know from the very beginning the importance of soil. So I think we are making good progress, but we have a long way to go.
Okay, thank you very much, Professor Sandoval.
I have another question. In the process of supplying organic matter to the soil, usually a very big percent of carbon is lost to the atmosphere. Is there any way to decrease this loss of carbon in the process? To
Thank
my
you.
knowledge,
Yeah,
it is
go ahead.
about 6%. I don't know if you agree with this situation, but one way to decrease or sequestrate more carbon is to reduce this percentage. Sorry.
I think your question on soil organic matter content is a very good one. Our soils, because of the traditional management, which is based on plowing, removal of crop residues for other purposes, or burning of biomass, have depleted organic matter content of the soil. It also led to I had a statistics in my slide, more than 500 gigaton of carbon has been lost from land, vegetation, and soil when we converted land from natural ecosystem to agricultural ecosystem. The loss of carbon from soil, organic matter, is estimated by many people, and the range of estimate is from 80 gigaton to about 140, 130 gigaton of carbon lost from the soil as organic carbon. We have also lost inorganic carbon, especially when you add nitrogenous fertilizers. The rate of decomposition because of acidification can happen in the loss of soil. Inorganic carbon as carbonates become CO2. So returning back carbon in soil can be done in terms of growing cover crops, conservation agriculture, returning crop residue, integrating crops with trees and livestock, agroforestry system. So the technical potential of land to sequester carbon globally is about 2.5 gigaton of carbon per year, organic carbon, 2.5 gigaton maximum. But remember that the fossil fuel consumption at present is about 10 gigaton of carbon. So maximum potential of soil between now and 2100, so next 75, 80 years, along with afforestation, is about reduction in CO2 concentration as much as 150 to 160 parts per million. That means about 330 gigaton of carbon can be put back in trees and soil by better agriculture between 2020 and 2100. For this, we need better policies to translate science into action. We need policies which encourage farmers to adopt agriculture, and it kind of encourages consumers like you and me. We all use food as a media, not only to nourish our body, but at the same time restore and improve soil health and the environment. So it's possible if we can find alternative to fossil fuel. It is possible that by recarbonization of land, global climate can still be within 2 degrees centigrade, no more.
Okay. Thank you very much. We have some questions in the chat, but probably for your time, it's quite impossible to answer all question. Probably next or later you can answer the question in the chat, Professor Lan. I know you are very busy. So
we can take note. You can send me the list of the questions from the chart, and
okay.
I'll send you a response in writing.
Perfect. Well, finally, I would like to tell you thank you very much. It was an honor listening to you about the really nice talk. The Postgraduados College, we are grateful with you, and probably I would like to see you very soon at Postgraduados College. Well,
yes.
We hope.
Thank you so much for the invitation, and I'm sorry that I could not come this time, but I'm looking forward to the visit at a convenient time in the future.
Okay, thank you very much.
Thank you.
Thank you. Thank you so much. Bye-bye.